the coding guy. Um, Yesterday was somewhat of a debacle. We finished a section in Code Fights. Let me pull that up for you real fast. Codefights.com. We were running through arcade mode, and I was kind of, I don't know, not bored, but I just wanted to try something new. So what I did is after I finished that last section, the smooth sailing, or sorry, after finishing Edge of the Ocean, I decided, oh, you know what I'm going to do? This is going to be so easy. I'm going to do this next problem. I'm going to use Clojure. No, it went awfully. It was a debacle because I forgot that in this world there's such a thing called functional programming languages, and I've never used one before, to be honest. In school, we always used C# or Java or C++, and these are all like object-oriented languages. You create objects and you act upon them. Whereas functional programming languages is just kind of like math class. Everything's a function, and then the output of one function is put into another function to evaluate. And that is just a fundamental paradigm shift for me. I've never used functional programming languages, but I thought I would do this stream. We're not going to do code fights today. We're going to work through some tutorials I was Googling at random. I'm going to work through it using the Coding Ground, or Tutorials Point has a really good selection of of online compilers and interpreters that you can use for every language. So if we need a playground to play in for new languages, this is probably what I'll use. And as you can see, they have Clojure right here. So I'm gonna go ahead and and I found this tutorial here on the right hand side. LearnXandYminutes.com /docs/Clojure. So I'm gonna start working through this today, just to play around with it. And I guess the whole point of the stream is to kind of show you how I learn new stuff. I learn by doing. I can't just read a book on it, so I gotta try it out. So, anyways, so let's get started. Go ahead and just, I can run this for fun, just for see if it actually works. Be disappointed if it didn't. Hello. Wait. It said hello world. Print line. Define an hello world username. Yes. Print line. Format hello something. Username. Oh, I see. The world is the so they created a new function here. First, they created a namespace. I think I recognize that. I don't know what this is. This is, I read about this earlier. This is the def keyword mixed in with the fn keyword. So you're defining a function called hello world. Here's the parameter, which is an array, which is a username. And then with that, in that function, what you do is printing something to the screen. Don't know what format is. Must be some sort of function, I guess. I recognize this from C++. This is a kind of a string formatter type thing. Each one of these is represented by a parameter that gets added on each time. What I'll do is, hello. I don't know if this will work. I'm just gonna try it out. Username and poop. I don't know why I'm childish. Sorry, guys. Poop. And so what I did is I added. I don't know if this will work. I added a parameter to the function, to that declaration, and then I'm gonna go ahead and pass that parameter in, like the username is being passed in, and I added another little thing here for it to print out. Is that an airplane? Oh, it must be an airplane. Okay, sorry. And I'll put haha. And see if that works. Hello world, haha. Success. So I had my first Clojure success, which makes me happy. Anyways, so now we can keep going, I think. I will delete this. Alright, so going ahead. Comments start with semicolons. Let's see if that's true. I'm a comment. Comment. I'm a comment. So this shouldn't do anything, right? Yeah. I'm a comment. That's nice. Clojure is written, so I'm just reading the tutorial here. Clojure is written in forms, which are just things, lists of things inside parentheses, separated by white space. Yep, I got that. The Clojure reader assumes that the first thing is a function or macro to call. The Clojure reader assumes that the first thing is a function or macro to call, and the rest are arguments. Okay, that makes sense. So everything in Clojure is wrapped up in parentheses like this. And inside this parentheses is just a list, right? But the first element of the list is always the thing that you're doing. So in this case, blah, blah, blah. So the rest are arguments. That makes sense. The first call in a file should be ns. Should be ns. Does it have to be ns? I don't know. Let's see if one of these down here works without me putting ns in there. So as you can see, oh man, my bitstream is my stream is not stable right now for whatever reason. Sorry about that. Anyways, looking at the this function, so we have this list. The first argument is what we're doing. We're doing addition, and then one argument, and then another argument, and then let's see if this works. Well, freaking, oh, you know what? I'm adding it, but I'm not actually doing anything. But I did see before. Print F. Is this gonna work? Print F, and then I saw that one function called format, right? And then I saw this. Is the N for number, maybe? Close, close, close. This is gonna blow up horribly. True or false? Please blow up in my face. Didn't do anything. Okay, whatever. How do you print stuff? How to print? How to print string Clojure? With print string. Print string, print string. Okay. So that works. Let's try that. Print string, print string. I don't know all this other business is. Let's just execute it. Okay, let's do you. Nothing's happening. Come on, print it. Print and more. Just print. Alright, you better freaking work this time. Foo! I got foo! I got foo, guys. I got foo to come out. So it's not true. You don't need this namespace call in a file to make it work. So, ha! But it says that you should. So we're going to do that. I'm going to add namespace coding guy. Just a coding guy. Because Because, yeah, I don't know. Print foo. We're not going to print foo. I want to print something else. I want to print hello world. That's what I want to print. Print hello world. You better print hello world. Yes. Okay, so I got that to work. So now, I'm just playing with this now. I'm going to see if a function, or this print function will take 2 parameters instead. Ready, set, execute. Yes, it did. So you see, I'm just trying, when you're learning a new language, or when you're learning anything really, the easiest, fastest way to learn is just to practice. Just practice it and experiment, because nothing can break. You know, you're not going to destroy anything by experimenting. See, that's the one good thing about being a software engineer or a coding guy, is that, you know, a mechanical engineer can't just experiment with building a bridge, you know, be like, oh, it fell down and killed a bunch of people. But programmers, you can experiment all day long and you're not going to hurt a thing. So, let's see here. So what am I doing? Oh, yeah, I want to see if this print function will take, so string will create a string out of all of its arguments. Okay. So if this function right here outputs a string, then I expect to be able to paste it as an argument to the print function, and it will also print out hello world. And for fun, I'm going to add my own little string. Haha. Execute. Hello world, haha. It worked just fine. Fantastico. So hello world, haha. Print it out. Great, so that works. What's the next thing on our plate today? Math. Math is straightforward. Okay, let's see how straightforward. Let's see how straightforward it is. I'm going to open up a function, try this out, and 1 + 1. Execute. 2! I'm going to add some more parameters here. See if that actually works. 15! So you can add, obviously, some of these functions you can add as many, I don't know if you can add as many arguments as you want, or if there's some sort of limit. But like, if I could make a loop right now, if I knew how to make a loop right now, I would probably loop into this function and try to blow it up, but I don't know how to do that. And from what I've heard, there are no loops. There's only recursion. So I'm sorry, but you're going to have to learn recursion if you want to stick with me learning Clojure here. By the way, I'm eating chocolate chips. They're delicious. Yes, I have a problem. Okay. So, print. And this is the add function. So I bet if I swap this out for that, execute 120 minus execute neg 13. So we got some negative values. Division. Execute. Huh. So, this is the first time I've seen this. Usually you do division on integers. You're either gonna, you're getting an integer division where it truncates the fractional part of it, or it's gonna promote it to a double and give you a double output. But in this case, it didn't do either. It looks like there might be a built-in rational type. You can actually preserve it in rational form. So that's kind of cool. Equality is equal. Okay, so equals 1, 1. Execute is true. do you take another parameter? I guess you do. What if I do this? Ha! Huh. So this is curious. I'm just curious out of this one. I'm wondering. Okay, so this equals the equality operator is equals, and it takes more than one parameter, obviously. So what if I use this? Right. This should evaluate to false, right? Because 1 is not less than 1. Yeah. So I expect this to be true. Right. True. Okay. I don't know if you guys can see that. It's pretty small. But anyways, so this worked, right? We evaluated it to true. But what if I add another parameter to this too? So my hypothesis is that this function is saying 1 is less, or 2 is less than 2 and 1 is less than 2. Maybe. I don't know. Let's find out. False. Yes. So if we change this to a 3, and we're back to true again. Yep. So even these functions can take more than one parameter. That's kind of cool. It's very different. Very different. Anyways, what's next on our list here? You need not for logic 2. Not true. Print. So if everything's a function, right? So I'll make this a not. And then add a parens on the end here. So not, and then I have my statement. So it turned to false, yes. So I can negate using the not as a function. So, let's see. Nesting forms work as you expect. Nesting forms works as you expect. Yes, it does. I've been doing that. As you can see, I have this print function. I have a not function. Oh, forms and Clojure. I have a print form, a not form, and a less than form, all nested together. So that works really well. Let's see. Types. Clojure uses Java's object types for booleans. Strings and numbers. Use class to inspect them? What does that mean, to inspect them? I don't know. I guess we're going to give it a shot here. Use my trusty print function to figure this stuff out. So class 1. What does this give? Oh, wait, sorry. I need to wrap this in parentheses. Anyways, sorry about that. So anyways, what does this do? So we can inspect the class type, class of 1. This is actually a Java long. So basically it's taking the literal, or the object maybe, and this is a function or a form that inspects it and tells us what Java type it is. What I read about Clojure is that under the hood everything is Java bytecode. So it's really interesting. So I changed this to a 1.0. I wonder if this will be float or something. Java.lang.float, or I don't know what it will be. Double. So that's kind of cool. Integer literals are java.lang. Okay, yeah. So there's a double thing. We just what? That's not cool. Can't just leave a 0 off. That's cheating. All right, execute. What a weird language. What a weird language. Anyways, okay. Anyways, class strings. Strings are always double quoted, and are Java lang string. So there's some languages like Python where you can use single quotes or double quotes interchangeably. So well, yeah, that's nice. At least They enforce consistency. Booleans, right? Let's do that. False. Boolean, I trust you. Nil. The null value is called nil, and what will it print out as? Class.nil. It's just nil. So what if I take off? What if I just print nil? Execute. Okay, it's still nil. Whatever. So what does that mean? It's a nil is a class and it's a literal as well. That's because it showed up as nil when I printed the class type, and then it also printed nil when I printed nil. So I guess what else could it be? I don't know. If you want to create a literal list of data, use single quote to stop it from being evaluated. Okay. So let's just paste that. So we know what happens if I print this without the quote, right? I execute it and I get 3. But if I add the quote here, what do I get? I get the whole function. So that means if I do this here, if I add this eval, then I should get my number back out, right? Okay, that's kind of cool. So I'm not sure how that's useful yet, but it's interesting that you can do that. I'm sure I'll learn. I'm sure I'll learn how that works later. Anyways, so you can evaluate stuff. Collections and sequences. Lists are linked list data structures, while vectors are array-backed. Vectors and lists are Java classes too. Really? Okay, so I want to try this. Class 1, 2, 3. Wait, so I don't need the quotes? Is that true? Persistent vector. I'm just gonna take the. I mean, you're still persistent vector. Okay, fine. But just print it out then. Now I'm just curious. Do I need commas? It printed the array. So if I put the commas in there, will it print the same thing? It did. Commas are optional. So learn that. That's nice. Not really. I actually just wish they would just choose one or the other. Oh, you know what? I read about this. Look at this. So if you put this in there, right? What does this look like to you without the stupid single quote, right? That's a freaking function call. So if I try to print this thing that's actually, what does it say it is? It says it's a list. Look at that. We threw an exception. So I'm saying you can't do that. But if we're saying no, but soft, we are simply, what is this called? We are creating a literal list of data. So then execute. Yes, 1, 2, 3. So I wonder if that means if I do something. Oh no, we did that already. Yeah, we added the plus here, right? And it'll just print whatever's there. Yep. Same thing. Cool. Very cool. Let's see. A list would be written just as 1, 2, 3, but we have to quote it to stop the reader thinking it's a function. Oh. Seriously? I could have just read that and saved us all that trouble. But whatever, it was fun. Also, list 1, 2, 3 is the same as 1, 2, 3. So there's a better way to do that with the list word. Collections are just groups of data. Both lists and vectors are collections. So what? What does that matter? Okay. I'm just going to try it. coal. Not cool. Coal. Coal. And we have execute. So what did I expect to happen? I expect 1, 2, 3 to pop out. What? My head. What does that mean? It's true that it is a list. I don't really know. I don't know how to take this right now. Collections are just groups of data. Both lists and vectors are collections. It just returns true. I don't know what that. So okay, let's try this. Is it? I want to figure out why it's truthy. Execute. You're still true. Okay, I don't know. I'll have to come back to that one. I don't really understand it that well. Okay. Sequences are abstract descriptions of lists of data. Only lists are sequences. Oh, I understand now. This question mark is a function call, like, is this a collection? Right? Okay. Coal. This guy is true. It's a list. It's an empty list. True. Now what if I do 1? Yes! I was right. So this function here with a question mark, I don't know if all of them have it or what, but it returned returns true if it's if the argument is a list. Does it take more than one function, or does it take one more parameter? True. What if I put a non-list in there? Oh, it just blows up. Wrong number of args. Pass to core/coal. Okay, so you can't do that. I broke Clojure. Let's not break Clojure anymore. Alright, so next on our list. A sequence needed only to provide an... Okay, sequences. Only lists are sequences. I'll just take your word for that one. A sequence need only provide an entry when it is accessed. So sequences, which can be lazy, they can define infinite series. What? Okay, whatever. Let's just try this. Range 4. Execute. 0, 1, 2, 3. Okay. I print range. What is range? Did I break Clojure? I think I broke Clojure again by giving it an infinite. I think this is an infinite loop because it's going through and printing every. I bet you if I wait long enough, it'll actually crash the compiler. So I'm gonna let that run while I keep looking here for that stuff. Let's see. A sequence only need provide an entry when it is accessed. So sequences, which can't be lazy, they can define infinite series. Yes, great. Use cons to add an item to the beginning of a list or a vector. Okay, this is useful. Object. I broke tutorialspoint.com. Don't know what that is. Mysterious pop-up message. And I'm just gonna stop compiling this. Here. Make you happy. Execute that one. Okay. So let's see. cons. So we add 4 to the array, right? This is an array. Oh, sorry. This is a okay, sorry. This is a list. No, this is a list. This is a vector. Whatever, I'm just gonna call it a vector. Vector 2, 3. Execute. 4, 1, 2, 3. Boom, boom, boom. So what if I add this? 4 and 3. Add those two. Oh man, what is it? Wrong number of args. Not all the streets are paved with gold, it seems like. But I understand. I understand. I like how it gave me the namespace right here. Kind of useful. Alright. Conj will add an item to the collection in the most efficient way. For lists, they insert at the beginning. For vectors, they insert at the end. It makes sense because with a link list, because you saw earlier, you said that one of them was implemented with a linked list, and one of them is implemented with a vector. Adding an item to a linked list is a constant time if you add it to the beginning, because you have the pointer to the very first element. Whereas vectors insert is amortized constant time, because as you insert stuff, you know, it's constant time to insert at the end because you have space at the end. You just index in and you insert. But once in a while you have to double in size, and that's the whole amortized cost thing. But it's still constant time. So what does that mean, though? I guess it means if you don't care the order. Yeah, if you don't care about the order, use conj. Wonder how these are related to each other. The con-s, concatenate s, maybe concatenate? That'd be my guess. I'm not really sure. Let's run it. What do you mean? I did it. I did stuff. 1, 2, 1, 2. Java.lang.long cannot be cast to Clojure. What did I do? I don't like that at all. Look at this. Look at this funky business. They have this function which looks like this and does kind of the same thing, except this parameter is here, and this parameter is the first one. This parameter is the first one. They flip-flop the parameters. Makes me not happy. Execute. 1, 2, 3, 4. And for argument's sake, I will simply do the thing where I delete it, swap it. 4, 3, 2, 1. Boom. Alright, I believe you. Use concat. Use concat to add lists or vectors together. To add lists or vectors together? Alright. We're gonna see if you hold your word. Hold you to your word here. I can't talk right now. So what we'll do is boom boom paren quote. Not quote, but... Oh, that's funny. The double quotes there. So it is quote. And then boom. Boom. Why do I have so many? Okay, yeah, sorry. Boom. Boom. I like how the IDE is like, oh, you made a string, but really, what did I do? I made a list. Sorry, make sure I'm using the right syntax here. I made a list. Wow. And then I made a list right here. Okay. Just execute it. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So cool. It does take any combination of vector and such and such. So concatenate works. Use filter map to interact with collections. Map. Use filter, comma, map to interact with collections. Okay. So map increment something. Just for fun, we're going to use that as a parameter. Map inc. And I'll add a paren on the end. Execute. 2, 3, 4, 5. Boom. So it incremented this thing that we made. Okay, I can kind of dig this. I'm starting to get the hang of it, understanding the whole syntax of these functions at least. Use reduce to reduce them? Okay. Reduce plus. Sorry, I'm getting ahead of myself, aren't I? Filter even? Let's give you a shot. Filter even. So filter. Oh, I'm gonna do odd. Odd? 1 and 3. Filter odd. How do I switch this? Oh man, I wish I knew I would play with this a lot more. Be like, I would see if I can add more parentheses or more parameters to this, not just odd. Anyways, let's take a look here. Use reduce to reduce them. Reduce plus 1, 2, 3, 4. So I see what this is doing. 1, 2, then wraps in a parens and pluses it. Then brings in 3, 1 and 2. Then brings in 3. Then brings in 4. That seems redundant for plus. Am I right? Okay, whatever, let's try it. Because my math is not very that skilled, but addition is commutative, right? Is that what it means? That doesn't matter what order you add them in? Whatever. I'm sure there's some crazy, useful, fun way to use this. So I'm guessing I can swap this with whatever I want. 24, yep. I bet you division's going to give me some crazy rational number, yep. And then minus 8. Cool. And plus, just for 10. Alright. Reduce can take an initial value argument too. Why would I want to use that? I don't even understand how that's useful, to be honest with you. print reduce conj. What does conj do? Oh, it adds stuff to the end. What does this do right now for us? 3, 2, 1. 4. 4, 3, 2, 1. Okay. So that means I can do any. Does that mean I can put any function all in here? What if I do not? I don't even know what that'll do. Not what? Oh, bad number of arguments? Okay. How about this? Haha. That's 2 arguments, right? Didn't like that at all. Blew it up again. Well, I keep destroying Clojure. I don't want to keep doing that, so we'll just move on. Functions use fn. So we're going to create functions now. This is important stuff right here. Use fn to create new functions. A function always returns its last statement. It always returns its last statement. Okay. So let's call this one. So, all right. Fn my func. I'll just put func 0. Then a parameter list. And then my statement, hello world. Or just hello. Right, okay. Now, func 0. I assume that means... Oh. I assume I probably need to wrap this in parentheses. Execute. Unable to resolve symbol, func 0 in this context. Oh, I see. This is... I'm skipping ahead here. I need the def n. So, wait, okay, hang on. Back up a second. Copy and paste. Execute. Whoa, what did I just do? I did not expect that at all. I thought I was returning a string. There is no string. Okay, well. What if I change it? I'm sure that's a string. Oh, they have it down here, don't they? This is how they did hello world down here. Which isn't fair, right? Because that's how I did it. Oh. This printed the function. It printed out this function. Like, not the... It didn't evaluate the function. Oh, what if I do this? Eval. This is gonna be fun, boys, girls. Look at this. Well, F you. It didn't work. Fine. Thought it was gonna work. Anyways, define. Define. Define and define. Define. Oh, I need to add this. What? Oh, I need to wrap it up in parens. It's just printing out the symbol information without it. Here's when I'm actually calling func 0. Hello. Sorry about that. Too many chocolate chips. So I was able to get my function working here with the hello world. you can, okay, so we did this, we did that. You can create a var using def. Cool, let's do it then. And giving it a value, I guess. Def x 1 5 x. Okay, how about this? Print x. Hopefully it prints 5. Okay, good. Now what if I do this, ramp it up? It'll blow up. I'd be like, you're not a function. Yeah, see that? It's Java lang.long, which is the number, cannot be cast to clojure.lang.ifn. Cool. But I bet you if we do class of x, this would be a long. Yep. Haha. Okay, cool. So x. Assign a function to a var. I did that. This thing is the list of arguments for the function. Define function hello name. String hello name. Hello name. Yes, I understand now. Concatenating the strings together. Which is actually how our hello world function that was first started actually worked, didn't it? Alright, I suppose we gotta try this out. And you guys, whoever's watching, you guys are welcome to follow along with me. I hope you can see this URL. There's no login required. Who are you? Cortana. No one uses Cortana. Let's see here. What was I doing? Making a function. Defen low. Or how about, no, I'm going to create another function. Add x, y. And how they do it here. So they take the parens. So this is, I'm guessing this is customary Clojure. And they add the parens at the end here. How about plus x, y? So that means if I do print add, I wouldn't be surprised if add's already a built-in function. I'm gonna call this func0. Nope, I'm gonna find out. Nope, because I won't know the difference. Func0, 1 and 2. So I expect this will call the function. 1 and 2 as arguments, and this right here, oh, missing a parentheses to close up this one. Execute. 3, yes, that's true, because 1 and 2 is 3. Wunderbar. So now, let's see. What time is it? It's only, I'm only got 2 minutes left, guys. I'm gonna get off because this is taxing my brain. I already did a full day of work. Today I learned, learned and relearned linear algebra just to do some stuff. So that was fun. Hello, did that. You can also shorthand this, create functions. Hello, so define hello to. Oh snap. This is weird. This little notation right here is what they use when, like in scripts and stuff, like shell scripts, when you're trying to access the arguments to your shell script, or the C in C++, the main, or C or C++, also the main argv parameter, you access it kind of like this. So that's interesting. There's a shorter way of implementing the function. I don't think I'll ever use this, to be honest. I'm just gonna skip over it actually. You can have multivariadic functions too. Multivariadic functions too. Okay. Oh, does that mean I can just overload them? Is that, why can't it just be like, you can overload the functions? Multivariadic, please. Anyways, guys, my eyes hurt. I'm gonna take a little break. Maybe I'll come back and play some Caves of Quad or something. But I hope you learned something. I learned a ton just now of this new language called Clojure. It's not new, it's just new to me. But I learned a ton, so I hope this video helps you. Please, follow me or watch my videos, learn some more stuff. Message me. I think my email might have showed up in the video somewhere. You can always email me. Whatever you want to do, contact me. Tell me how these streams are going. Tell me what I can do to improve, and I'll definitely try my best, because I would definitely want to put out high quality content for you all. So, anyways, guys, thank you guys for coming and watching. My name's Eric, and I'm just a coding guy, and I'm signing off.